We like to think we've got a handle on science, right? Especially something like the weather. But what happens when nature just rips up the rulebook and does something completely unexpected? Today, we're diving into the weather events that were so extreme, so totally out there, they forced scientists to go right back to the drawing board. And I'm not talking about, getting your weekend forecast a little off. I'm talking about forecasts that were fundamentally, foundationally wrong. Events that our best, most sophisticated models insisted were simply impossible. These weren't just bigger storms or hotter days than we'd seen before. No, these events showed us things that flat out contradicted our core theories. They were, in a way, terrifying lessons from nature, showing us all the blind spots we didn't even know we had. So let's start with the events that were just shocking for their raw, unbelievable power. These are the storms and heat waves that didn't just break records, they absolutely obliterated them and reset the scale for what we thought was even possible. First on the list, Hurricane Patricia back in 2015. This thing wasn't just strong, it turned into an absolute monster at a speed that no computer model had ever seen. It basically went from a pretty standard tropical storm to a catastrophic Category 5 hurricane almost overnight. And get this number, it is staggering. Patricia's winds intensified by over 120 miles per hour in just 24 hours. Scientists had always thought there were physical limits, kind of like a speed limit, on how fast a storm could suck up energy from the ocean. Well, Patricia just blew right through that speed limit and forced a total rethink of our models for what we call rapid intensification. And then you have Typhoon Haiyan in 2013, with winds so powerful they were literally off the charts. Some instruments couldn't even measure them. But the big lesson here wasn't just about the wind. See, before Haiyan, our models mostly looked at the ocean's surface temperature. Haiyan taught us that the deep ocean heat content, all that thermal energy stored hundreds of feet down, is the real fuel tank that can create and sustain these monster storms. This quote really says it all, doesn't it? It perfectly captures the pure shock of the 2021 Pacific Northwest heatwave. Temperatures soared past 49 degrees Celsius. That's 121 degrees Fahrenheit, in places famous for being cool and mild. The numbers were so extreme, so far outside anything predicted, that some of the experts thought their own instruments had to be broken. Turns out the culprit was something called a heat dome. But it wasn't just one thing. It was a perfect storm of factors. A stubborn high-pressure system, super dry soil, and background warming all reinforcing each other. It was like a feedback loop from hell. This event forced scientists to start taking compound extremes seriously, where different factors don't just add up, they actually multiply each other's effects. Okay, next up, let's talk about the paradox of water. We're going to look at events where rain and snow behaved in ways that seem to make no sense at all, challenging some of our most basic ideas about precipitation. When you think about hurricane danger, you probably think of wind, right? High speeds, blowing things over. But Hurricane Harvey completely changed that conversation. It wasn't actually that remarkable for its wind speed. The real danger was the fact that it just wouldn't move. And the result was just catastrophic. Harvey just sat over Texas, dumping over 150 centimeters, that's almost 60 inches of rain on some spots. The scientific focus had always been on a storm's intensity. Harvey proved that a storm's immobility could be even deadlier. It forced modelers to try and understand the weak steering currents in the atmosphere that basically let the storm get stuck in park. Now for a fantastic paradox, a real head-scratcher, the Snowmageddon blizzards back in 2010. It just seemed to fly in the face of global warming, right? How on earth could a warmer planet produce more snow? It feels wrong, but the science behind it, well, it revealed something critical. It's actually a pretty simple chain reaction. First, warmer oceans mean more evaporation. All that water has to go somewhere, so you get more moisture in the atmosphere. Then when a winter storm rolls through, there's just way more moisture available to fall as precipitation. And if it's cold enough, that means you get heavier snow. So there's the paradox. A warmer world can actually hold more fuel for massive winter storms. And this exact same principle, more heat, more moisture, more precipitation, is what's behind some extreme rain events too. The Queensland floods were supercharged by unusually warm sea temperatures that created these huge plumes of moisture. And in Kerala, India, the models completely missed a devastating chain reaction where one low-pressure system followed another back to back to back, revealing a huge blind spot in how we understood monsoon dynamics. All right, now we're going to pull the camera back a bit because some of the biggest lessons science has learned came from these huge, continent-spanning patterns and feedback loops that our models just hadn't been able to grasp until it was too late. Okay, so first we need to get a key concept down, the atmospheric blocking pattern. But don't worry, it's simpler than it sounds. Just think of it like a giant traffic jam in the sky. A huge, high-pressure system just parks itself for days or even weeks, and it doesn't let any other weather systems get by. And that's how you end up with weather that gets stuck, whether it's brutal heat or nonstop rain.
And that's exactly what was behind the devastating heat waves in Europe and Russia. The models at the time just had no idea these blocks could last so long or be so intense. But these events also pointed to a really troubling new idea, that rapid warming in the Arctic might be messing with the jet stream, making these atmospheric traffic jams a lot more common.
Which brings us to one of the most unbelievable phenomena I've ever heard of. It happened during Australia's Black Summer bushfires. We always think of fires as something that happens because of the weather. But these fires, they got so big, they started creating their own weather. They created these things called pyrocumulonimbus clouds, literally fire-generated thunderstorms. The intense heat from the fire acts like a massive piston, punching smoke way up into the stratosphere. It's like a small volcanic eruption. And this doesn't just spread smoke around, it can actually change atmospheric patterns across an entire hemisphere. Black Summer proved that extreme fires aren't just a result of climate, they can become a major climate-driving event all on their own.
So, after looking at all these insane rule-breaking events, what's the big takeaway? You might think it sounds like science is just failing over and over, but actually, the exact opposite is true. Every single time a model breaks, it's a chance to build a much, much smarter one.
This is how science really moves forward. It's not always a neat, gradual process. Sometimes it takes a massive confrontation with something we didn't know to make a real leap. These events, as destructive as they were, gave us priceless data that pushed our understanding forward by years, even decades.
And this shift in thinking is just profound. We learned that a hurricane just standing still can be way more dangerous than one that's moving fast. We learned that, weirdly enough, a warming world can actually supercharge a snowstorm. And maybe most incredibly, we learned that fires can get so big that they stop being a result of the weather and start creating it.
So, in the end, every single one of these impossible events becomes a new part of the foundation. They show us our weaknesses and force us to add new variables we never even considered before, from deep ocean heat to the stability of the jet stream. Our models have to evolve just as fast as our planet is changing. And that really leaves us with a final, pretty sobering thought. These events have totally rewritten the rules of what we thought we knew. But as our climate keeps changing in ways we've never seen before, you just have to ask yourself, what seemingly impossible event is waiting around the corner? And what new rule is nature about to break next?